Dear students, in this video, I am going to explain you glass electrode, which is a glass membrane ion selective electrode. We have already discussed the components of ion selective electrode. So the glass electrode is also made up of the three major components, that is the internal reference electrode, internal electrolyte, and the membrane. Now, because the glass electrode is used for the measurement of pH, that is the hydrogen ion concentration in the test solution. Therefore, the electrolyte which is filled in the glass bulb should also contain hydrogen ions. And this is the reason we fill the electrolyte as internal electrolyte made up of zero point 0.1 normal hydrochloric acid. Let us see the details of glass electrode. So, as we have discussed in the previous video about the ion selective electrodes, that they are made up of three components. So, glass electrode is no exception. It is also made up of three components, that is the internal electrode made up of silver chloride, the internal electrolyte which is zero point 0.1 normal or zero point 0.1 molar hydrochloric acid, because the normality and molarity of hydrochloric acid is same, and the membrane which is made up of glass. Now the glass electrode, as the name suggests, it is made up of glass and it is in the form of a small tube, narrow tube. But the entire electrode is not made up of same glass. The lower end of the tubular glass is modified into a small bulb, and this bulb is made up of special glass which is called the soda glass, which contains the zero point 0.1 normal or zero point 0.1 molar hydrochloric acid, into which dips the internal reference electrode also. When the bulb is immersed in the test solution, whose pH we want to determine, it develops a potential due to the difference in the concentration of hydrogen ions outside and inside the membrane. And this potential is determined by connecting this glass electrode to some external electrode. It can be calomel electrode or a standard hydrogen electrode. Usually we take saturated calomel electrode for this purpose. The potential is determined by connecting the two electrodes with the voltmeter, and the potential is then read as pH units. Now let us see the principle on which the glass electrode works. The bulb, which is very special because it is made up of thin walled soda glass, and in the glass bulb is filled 0.1 normal hydrochloric acid. Let the concentration of the hydrochloric acid inside the glass bulb be C1. And when this bulb is immersed in the test solution with a concentration say C2, it develops a potential across the glass membrane. And this potential is denoted by capital E small b, EB, and is called the boundary potential. So the boundary potential EB can be written mathematically as the difference between the potential outside the membrane and inside the bulb, that is E2 minus E1. Now we know from the Nernst equation that E2 and even can be written as RT by NF ln C2, because E2 is because the concentration of the test solution outside the bulb, and C1 is the concentration of the hydrogen ions inside the glass bulb. So we can write from the Nernst equation RT by NF ln C2 minus RT by NF ln C1. Since the hydrogen ions inside the bulb remains constant, therefore RT by NF ln C1 is a constant. The equation 2 then can be modified as RT by NF ln C2 minus constant. Now because it is a constant, so we can write it RT by NF ln C2 plus with the bracket minus constant, or RT by NF ln C2 plus constant. Or it can be written as constant plus RT by NF ln C2. On substituting the values of R, T, N, F and Ln at 298 kelvins, the equation EB can be written as constant plus 0.0591 log C2, where C2 is hydrogen ions concentration of the solution. And we know that negative log of H ion concentration is equal to pH. So the equation 7 can be written as EB is equal to K minus 0.0591 pH. K is any constant. Therefore, this equation 8 can be used for the determination of pH of any given solution under test. And this is the principle of glass electrode. Now let us see the construction of the glass electrode. The glass electrode consists of a long glass tube whose bottom is modified into a glass bulb, and 0.1 normal hydrochloric acid is placed in this bulb. The silver chloride electrode is immersed in this, which acts as the internal reference electrode. The bulb is made up of a special glass called the soda glass, whose composition is sodium oxide, calcium oxide and silica. The percentage of sodium oxide is 22%, calcium oxide is 6% and silicon is 72%. The electrode is reversible with respect to hydrogen ions. We can represent the electrode as I have shown here. First we will write the internal reference electrode, that is AgCl. Then we will write the internal electrolyte, that is 0.1 normal hydrochloric acid, and then the glass membrane. The working of the glass electrode is very simple. As we know that the soda glass is the important constituent with which the glass bulb is made up of, so it contains sodium ions. When we immerse this electrode, that is the glass bulb, in the test solution, the sodium ions present in the soda glass gets exchanged with the hydrogen ions of the test solution, and this can be represented here in the equation. NaGl, sodium ions present in the soda glass, will get replaced by the hydrogen ions and sodium ions will be liberated in the solution. But this is a reversible reaction. So, the glass electrode potential Eg is a sum of both boundary potential Eb and the potential due to the internal reference electrode, that is EAgAgCl. Now if we consider the concentration of the two electrolytes inside the bulb and outside, that is in the test solution, is same, then Eb will be 0. Still there will be some potential, and this is due to the layers in the glass material, because we all know that glass is a supercooled liquid and all liquids have layers. So there will be some potential in between the layers of the glass, and this is termed as asymmetric potential. So this cannot be ignored. So while writing the glass electrode potential, we should also consider the asymmetric potential, and then it will be the sum of the boundary potential plus the internal reference electrode potential plus the E asymmetric potential. But from the principle, we know that boundary potential EB is equal to K minus 0.0591 pH. Therefore, we can write EG as K minus 0.0591 pH plus EAgAgCl plus E asymmetric potential. Now, we know that for a particular glass, the K, EAgAgCl and E asymmetric is a constant and it can be denoted as E naught G. Therefore, we can write the equation Eg is equal to E naught G minus 0.0591 pH. And this equation we can use for the determination of pH of any given solution using the glass electrode. Let us see the advantages of the glass electrode. The glass electrode can be used in presence of oxidizing as well as reducing agents. It cannot be poisoned easily. Even small quantities of test solution can be used for the determination of its pH. It can be used to determine the pH of buffers also. It is very simple to operate and it is very portable. But there are certain limitations of glass electrodes. It cannot be used beyond pH 9 as it starts showing the alkaline error. Similarly, it cannot be used below pH 1. It cannot be used in pure alcohol also because it does not function satisfactorily with the alcohol. So these are major disadvantages or limitations, but there are many advantages of glass electrode. We can take it anywhere and we can measure the pH of any solution, which is very important these days. Therefore, glass electrode is very important ion selective electrode. Thank you.